Okay, so let's say that given this linear function, we want to complete a table of values. Then we'll use the table to make a graph. And based on the graph, we'll identify the domain range, the family of functions, and the intercepts. Let me use this paper as scratch. So let's fill out the table first. Here's how this works. Here's a given x. I need to know the y that goes with it. So what I'm going to do is I'm going to write the equation all over again. But instead of x here, I'm going to type in, or I'm going to write -7. And now my goal is to get y alone. So check this out. -6 times -7 is 42 plus 5y equals 20. Let me subtract 42 from both sides so that 5y equals -22. Then if I divide by 5 and turn this into a decimal on a calculator, it would say -4.4. So that is the y that goes with this x. Let's try this again, but this time let me plug in -6 in for x. So that'd be -6 times -6 plus 5y equals 20. That's 36 plus 5y is 20. If you subtract 36 from 20, it will be -16. And when you divide by 5, it should be -3.2. So check this out. We want more points. So I have to make a decision. What x's should I use? Well, let me go with the flow. Look, -7, -6. How about like -5? And maybe like -1, 0, 1, 2. You don't have to go in order per se. You can jump around. So let me do the same thing with all of these x's. Take all these numbers one at a time, plug them in for x, and then solve for y. If you do that, here's what you should get. So very quickly, I typed all of these x's in there one at a time, and I got the corresponding y's, and I got all of these points right here. So let me just take these x's and y's and throw them onto the x and y axis. Recall how this works. Look at the first point. So -7 means go left 7, 1, 2, 3, 4, 5, 6, 7, and then -4.4. So you go down 4.4. 1, 2, 3, 4.4 is like right there. Now the next one, -6 is here. -3.2, -1, 2, 3.2 is like right there. Now -5, 1, 2, 3, 4, 5, -2 there. -1, 2.8, that's like -1. 2.8 is positive, so I go up 2.8. 0, 4, so 0 means here. 1, 2, 3, 4, up. And then 1, 5.2, like right there. And then 2, 6.4, 1, 2, 3, 4, 5, 6.4 would be like right there. And so these are all the points that came from this table. Notice that if you connect the dots and put arrows, this is a line. It is a linear function. So when it says family, I'm gonna write the word linear because it's a line, so it comes from the linear family of functions. Now, the domain and the range. Look, anytime you have a line that looks like this, or like that, or like this, anytime you have a line that's crooked, then the domain and the range are going to be all real numbers. All real numbers. That means that you can plug in any x and any y into this equation and get something back. So this line, it goes left and right forever and down and up forever. Left and right is for the domain, down and up is for the range. So all real numbers, all real numbers. Sometimes math teachers use this symbol. That symbol just means all real numbers. Now, the only thing left to do are the intercepts. So here's one way of doing it. So to find the x-intercept, you let y equal 0. So write this equation again, but instead of y, you can put a 0 in for y. So if I put a 0, 5 times 0 is 0, so that's gone. So it's just -6x equals 20. And if I divide by -6, I get like if you reduce that fraction, it's like -10/3. So for the x-intercept, it would be -10/3, comma 0. And it's a 0 for y because we plugged in 0 for y. Now let's do vice versa. To find the y-intercept, you plug in 0 for x. So let me do that right here in this little corner. So I'll write the equation again, but put a 0 in for x. So it'd be like this, it'd be like that. And then 0 times that is gone. So it's just 5y equals 20. If you divide by 5, y is 4. So here, for the y-intercept, it's 4 for y and 0 for x. And that's not a surprise because that was actually in our table. So, in short, to find the x-intercept, you put a 0 for y, and then you discover whatever you get for x. To find the y-intercept, you plug a 0 in for x, and then whatever you get for y, you get for y. And it's not a shocker that the graph agrees with it. For instance, 0, 4 is right there. That's like negative 3.3 as a decimal, which is one, it's like right there. You see that? So these 2 points are on the graph, so everything is in agreement. So again, domain range would be all real numbers if your line is like this or if your line is like that. If your line is perfectly vertical or perfectly horizontal, we have a different discussion. But as long as the line is crooked in any sense, all real numbers for both. And then pick x's that you want to use for your x column, plug them in one at a time into the equation to get the corresponding y's. So with that in mind, try your problem and let me know if you have any more questions.